Right, recall that when we differentiate e to the power of ax plus b, what do we get? We will get e to the power of ax plus b, right, and then times differentiation of your ax plus b. Right, so when you differentiate ax plus b, you get a. So the expressions you get will be a times e to the power of ax plus b, right, where your a is not equals to 0. Okay, so we're going to do a reversed actions, to do a reverse action and see what happens. So to do a reverse action, we just have to add the integration sign. Okay, then the next step is to multiply by dx on both sides. So you will end up getting this. Alright, then the next step is that recall that differentiation is the integration is the reverse of differentiation. Hence, what you are left on the left hand side will be e to the power ax plus b. And then on the right hand side, you can actually, because a is a constant and a not equals to 0, so you can actually just extract the a from your a e to the power of ax plus b. Alright, so we're actually interested to find the integrations of e to the power of ax plus b. So this one will give us, so I need to divide both sides by a, right? So that will give us e to the power of ax plus b divided by a, and we can write it as 1 over a e to the power of ax plus b. And because we're dealing with indefinite integral, so remember to add a constant, arbitrary constant c. Alright, let's write down the formulas that we have learned earlier on. To integrate e to the power of ax plus b, right, the formula is 1 over a, then times e to the power of ax plus b, then plus the arbitrary constant c. Alright, now let's examine the formula very carefully. It is very important that you understand the formula and then so that you can apply it correctly. Now, so to apply this rule, you have to ensure that your exponential is expressed in the form e to the power of something. So example, like e to the power of 2x minus 1, e to the power of x, or e to the power of half x. Okay, then you can actually apply the formula. If what you're given is like 1 over e to the power of ax plus b, right, then you can't apply the formula directly. You will have to do some manipulations to this. You will have to convert this to e to the power of something. So it must be always e first and then to the power of something before we can apply this rule. So this is something you must remember remember well. All right. So let's check. Let's check if what you're given in part A. It's fits the rule. All right. So yes, right. So this is e to the power of something. It's e to the power of something. Right. So we can apply the rule. So to apply the rule, if it's e to the power of something, then the first step is to just write down what you're given. Right, then times 1 over differentiation of 2 minus 3x. So you differentiate 2, you get 0, differentiate negative 3x, you get negative 3. So you end up getting 1 over negative 3. So 1 over negative 3 can be written as negative 1/3. Alright, and then remember to add an arbitrary constant C. Okay, let's look at part B. Now, so if you look at part B, right, I cannot apply the formulas directly. Why? Because it is not e to the power of something. Can you see that you actually have a square root there? It must be e to the power of something. But here we have a square root. Okay, so we need to do some manipulation. So if you were to recall, square root a is actually a to the power half. A not equals to 0. Right, so in this case here, e to the power of 2x minus 1, it's square root of e to the power of 2x minus 1 is e to the power of 2x minus 1 to the power half. Okay, and there's another rule that you have to remember. This is one of the rules in the chapter on indices. Right, so we can simplify it to be, so we can have 2x times half, that gives you x. And then negative 1 times half is negative half. Alright, so now this is exactly like e to the power of something already, so we can apply the rule. So times 1 over differentiation of x minus half. So you differentiate x, you get 1, differentiate negative half, you get 0. So this will give you 1 over 1, that gives you e to the power of x minus half, then plus a arbitrary constant c. But let's look at two examples where you cannot apply the rule for integrations of exponential functions directly, meaning you have to do some manipulations to the expressions given. So right, if you look at part C, okay, you now, all right, let's go back to the algebra. Let's go back to if you're given like a plus b squared, what do? You expand it, right? You expand it to get a squared plus 2ab plus b squared. So similarly, we're going to do that for these exponential functions. Okay, so in this case here, e to the power negative x, you can liken it to the variable a, and e to the power x, so variable b. So that's put into the algebraic identity there. So they'll give us a squared. So a is e to the power negative x, to the power of 2, then plus 2a b plus b squared, and then your dx. Alright, so if you simplify further, that will give us e to the power negative 2x. This one here will give us e to the power negative, so it's negative x plus x, so they give you 0. So e to the power of 0 is 1. Alright, so now we can actually integrate it term by term really. So we can integrate e to the power negative 2x dx plus integrate 2 dx plus integrate e to the power of 2x dx. Alright, so integrate this one here, we will get e to the power negative 2x times 1 over differentiation of your negative 2x. So differentiate negative 2x, you get negative 2. Alright, so integrate 2, you're actually integrating x to the power of 0, right? So you will get x, okay? Because you will take this one here, you will take 0 plus 1, gives you 1, then divide by 1, so you get x. Here you get e to the power of 2x, then times 1 over 2. So 1 over negative 2 can be written as negative half. 2x, you leave it as 2x. This one can write it as e to the power of half times e to the power of 2x, then plus the arbitrary constant c. Okay, so in this example here, you can see that you have to understand the formula correctly so that you can apply it correctly. Alright, so if you look at part D, okay, likewise you see that you can't apply the formula directly because this is not e to the power of something. It's actually something over e, right? So what we're going to do is we're going to separate it. Okay, separate into like this: 9 over 4 times 1 over e to the power of 9x minus 5. Okay, how did it happen? 9 times 1 will give you 9. Then 4 times e to the power of 9x minus 5 will give you 4e to the power of 9x minus 5. It's like, for example, if you have this 3 over 4, you can actually write it as 3 over 1 times 1 over 4. Right? Just multiply the numerator, multiply the denominator, you will get your fractions, right? So I'm using the same concept, so if you learn much younger. So 9 over 4 is actually a constant. You can actually take it out from your integration sign. And this, okay, this one here, we will have to apply. Some of you may have already forgotten this. Actually, the rules that you learn in the chapter indices are very important. Okay, if you were to recall, we have this rule where 1 over a to the power n. A to the power n is a positive. You have a positive index, n is positive. So if you want to convert it to a negative, it's a to the power negative n. So it must be 1 over a to the power n, then equals a to the power negative n. Okay, here I need to tell you that a to the power n is not equals to a to the power negative n. It's like it's the same meaning as saying half is not equals to 2 lah. So if you want to convert 1 over a to the power n into negative, can you see that your n now become negative n? And instead of denominator, it becomes a numerator. So from a denominator to become a numerator, you have to negate the power. Okay, so if you look at this here, your exponential is denominator. If you want to bring it up to the numerator, then you have to negate it. What's the meaning of negate it? Negate it means you just multiply with a negative, multiply the power with negative 1. So you just multiply the power, which is 9x minus 5, with negative 1. Okay, so what do I get? I'll have e to the power of negative 9x plus 5. Okay, so now I can actually integrate it already, because it's actually e to the power of something already. So I just write down, the 9 over 4 must be there first. Then times e to the power of negative 9x plus 5, then multiply by 1 over differentiation of your power. Differentiate 9 minus 9x plus 5, you get negative 9. Differentiate negative 9x, you get negative 9. Differentiate 5, you get 0. Okay, so now we can put them together. So we will have 9 over 4 times negative 1 over 9. Wait. I think I don't like the way I write it. So we just put them together. I think we put brackets better. So it's 9 over 4, bracket it. Then 1 over negative 9 can be written as negative 1 over 9, just bracket it. Then e to the power of negative 9x plus 5. I think bracket is a very, very useful operations. It's easier for presentations, when you use bracket, rather than use times, because you can't have times and minus two operations side by side. Alright, so now you can multiply the numerator. So 9 times 1 gives you 9. Then 4 times negative 9 is negative 36. Oh, we can simplify it, simplify it to get, you can just use a calculator. 9 over 4 times negative 1 over 9. You get negative 1/4. Then e to the power minus negative 9x plus 5. And then plus an arbitrary constant c.